A compelling law enforcement example that shows the ability of centrifuge analytics to aggregate, analyze, and visualize data is the DC sniper case. One of our engineers worked on the FBI's lessons learned analysis in the aftermath of the events that terrorized the Washington, D.C. area, resulting in 10 fatalities and 3 people wounded over the course of 3 weeks in October of 2002. In 2002, there wasn't the ubiquitous E-ZPass and traffic camera monitoring that exists today. So local police jurisdictions and federal authorities collected license plate information around each of the shooting incidents in the early days of "if you see something, say something." This collection of license plate information was then put into Access databases and Excel spreadsheets and analyzed manually. Centrifuge Analytics aggregates data from Access, Excel, as well as enterprise data to easily analyze information in tabular views and allows users to holistically visualize data across business intelligence, timeline, geospatial, and link analysis views. Using the DC sniper data, Centrifuge will first start with tables of license plates, and each of the shooting incidents is represented in the link chart as a node surrounded by links to each of the individual license plates, and on the geospatial view based on the latitude-longitude. We start by looking at what turned out to be a wild goose chase, searching for a white van that had the whole region terrified. When we go into the column charts and drill down into the column that is labeled white van, we see that a couple of vehicles were reported near multiple shooting incidents. When they're projected onto the link charts and geospatial views, we see that the link chart shows the connectivity and the geospatial view shows the locations, all clustered around the Rockville, Chevy Chase, Wheaton area in Maryland. But these all turned out to be delivery vans just making their rounds. If instead we drill down into the column labeled blue sedan and we look at the license plate with the highest number of reports, we immediately see a different pattern. The suspect vehicle is reported 14 times, 13 times as a New Jersey plate and once as a Virginia plate, at 7 of the shooting incidents, and as the only license plate reported near the shooting incidents in both Maryland and Virginia. The orange halo shows the broadcast feature of Centrifuge that allows the same objects to be highlighted or filtered between views, providing a coordinated, holistic view. Now that we've identified the suspect vehicle, we can isolate that information and use Centrifuge's link-up capability to simulate performing a DMV check to get the VIN number and in turn the history of ownership, including the current owner, who turned out to be John Allen Muhammad. Also using a link up, we simulate checking John Allen Muhammad's arrest record across multiple states, which included a restraining order violation, assault, armed robbery, and an immigration violation when he tried to get Lee Boyd Malvo over the Canadian border into the US. All the data was there, and we just needed better data collection and better analysis tools to get a faster conclusion. In addition to law enforcement, Centrifuge Analytics is used across the U.S. intelligence community, the Department of Defense, and the Department of Homeland Security for applications as diverse as defensive cyber, insider threat, all-source intelligence analysis, and fraud, waste, and abuse detection. With Centrifuge, all you need is a web browser, a network connection, and the appropriate credentials. The platform is in use every day on a variety of classified networks, supporting the most sensitive use cases. Data can be dynamically combined from multiple sources without worrying about accidental data spillage. The platform is easy to use and allows more experienced users to create templates for novice or less tech-savvy users. Centrifuge was developed to quickly and easily integrate with other third-party COTS, GOTS, and open-source tools that complement the platform for additional geospatial, NLP, big data analytics, and AI ML applications, and ensures that the software investment is never obsolete and can change as the mission changes.